the introductions. Basic hydrology explores the hydrologic cycles, including surface runoff, groundwater flow, transpirations, evaporation, infiltrations, and stream flow. Understanding hydrological terminology, watershed areas, and runoff parameters is crucial. Accurate modeling is complicated by rainfall and runoff parameters, soil infiltration properties, natural surface retentions, and drainage patterns. Understanding these elements is essential for meaningful interaction with basic hydrology, as they directly impact water resources, floods, stream flow, and hydraulic structures. So next is theory. The theory of rainfall and runoff in hydrology suggests that rainfall triggers various processes that results in runoff with four possible outcomes: evaporations, seepage, vegetations, captures, or surface runoff. Factors like geography, soil properties, land cover, and precipitation intensity influence runoff amount. Understanding these relationships is crucial for efficient water resource management and flood mitigations.
This is the apparatus that we use: rain god, water level, supply tank, stopwatch, switch box, and measurement wheel. In case 1, a configuration was made so the rain god would have a zero slope. Second, guaranteed that there was no water in the sand. Next, the stopwatch was started at the same time that the pump was turned on. Every 35 seconds, the discharge and rain god measurement were recorded. The discharge continued to decline concurrently, and measurement were recorded every 35 seconds until a stable value of 5 continuous measurement was obtained. Case 2 rain god was then positioned at a 2 mm slope. The information was gathered and computed.
This is result and calculation for case 1, and this result and calculation for case 2.
Part of discussion: case differentiation. Case 1, 0% slope, discharge value fluctuated in an unstable manner, reading gauge increased until 305 seconds, then returned to the initial value. Water level remain constant at 245 seconds with 36 mm. Case 2, 3% slope, initial increase in discharge from 0.0000033 meter cube per second to 0.00038 meter cube per second. Fluctuated with slight increase and decrease until 340 seconds. Reading gauge show 3 mm at 35 seconds and 8 mm at 340 seconds. Comparison using discharge graph. Example, case 1 peak at 0.00038 meter cube per second at 245 seconds. Case 2 peak at 0.00038 meter cube per second but at 280 seconds, indicating a 35 second delay. Observation on slope impact: no significant difference observed due to the closed slope value 3%, suggest trying a steeper slope like 5% for case 2 to potentially reveal more distinct difference in the graph.
So now I will begin my part, which is the conclusions. In this lab, basic hydrology, rainfall runoff process is complexity and challenging accurately. So we are difficult to get and the accurate result from the laboratory because they are affected by a lot of the factor. One of the factor is natural surface detations, and second factor is the soil infiltration characteristic, and the third factor is the dry egg system. So runoff is the one most important hydrology component because it has a relationship to the quality of water supply and other hydraulic control system. Water level become constant and decrease because the rainfall exceed the rate of the infiltrations of soil. So in the daily life, the fluid management and the design dry egg system, we need to use the rainfall runoff because that is the important for us to save the cost when we design the dry egg system. In this laboratory, the application step is we need to ensure the time taken accurately every 30 second times record reading of the water level. So we also need to ensure the soil is in the dry and the flattened conditions before conducting the experiments, because the characteristic of the soil will affect the result in this experiment. So make sure the ice is perpendicular to the scale when taking the measurements of water level, because this is the important precaution step for us to avoid the error when we get the water level readings. That's all for my presentations.